Hello students, sorry for the delay. Let's start our recording of lecture number 3. So today we'll be covering the structure and collections in the C sharp. The first thing is first, that structure. It's a value type entity. Remember that we talk about that we can pass a variable or pass up some data between different methods by reference and by value. So structure is passed between different methods as a value, not by a reference. So that is a one difference between the struct and the class. When we look at the structure or the struct keyword, when we are defining the thing, it can have the properties, it can constructors, it can have fields, it can have methods. So it seems to us that it is more like a class, but actually it is not like a class. Class is a reference type entity. Whenever we are passing a class from one method to the other, it is passed as a reference. On the other hand, struct is a by value type entity. Okay, so that is the one of the main difference between the uh, structure and the class. So define using the struct keyword. So whenever we are defining that particular structure, then we need to use the struct keyword. So there are some limitations within the struct declaration. Fields cannot be initialized unless they are declared as constant or static. So we cannot say in the class we can say that we have a class, private int my int is equal to some value, but here in the structure we cannot initialize unless and until they are the constant. We can define the constant value which never change in the program, and then or either it is a static one. The structure cannot declare a default constructor, so there is no default constructor in the structure, so we cannot define or override or change that particular specific thing. Yes, we can have the constructor which can take some parameters, okay, but we can't have the default constructor. A finalizer or destructor cannot be defined in the class because it is more like a value type. So whenever that's go out of scope, it will automatically delete it from the memory using the garbage collection of the C sharp. But we don't need to define the destructor for that particular specific structure. We cannot define. We can define in the class, but we cannot define in the structure. Structures are copied on assignment. So whenever we are assigning one structure or one variable to the other which are of the structure type, so it will make a copy of that particular specific value and then assign to the new variable. Structures are value type and classes are reference type. So these are the few limitations and differences between the structure and the other and the classes. Again, the other thing is there is no inheritance. I think in the week 5 we will be discussing about the inheritance. What is an inheritance, how we can do that. But with the structures we can't do any inheritance. With this we can't create a parent and child relationship, but on the other hand in the classes, yes, we can. It can implement the interfaces. What are the interfaces? When we will discuss it, you can say that it is something which help us to define a few things which are common in something, and then we can, but definitely we will be coming back to on more details about the interfaces later in this course. A struct can be used on a null as a nullable value. We can assign a null to the structure and can be assigned a null value. Members cannot be specified as abstract, virtual, or the protected, because abstract, virtual, and the protected, these are more related to inheritance. Virtual methods, and we will talk about when we talk about inheritance what is abstract. We also talk about when we talk about the inheritance what is an abstract meaning. We see that the protected is a modifier. Only those protected mean that they are accessible only in the derived classes, and because there is no inheritance with the structure, so we can't make anything protected because there is no child relationship or parent-child relationship that exists in the structure, so we cannot define. So we can't have the members which are abstract, virtual, or protected, which are actually some have some meanings for the inheritance, and because there is no inheritance in the structure, we don't need them in the structure itself. Structures are faster than a class because class is a more heavier object as compared to structure. It's a by value and that is a by reference, and then it also has some other phenomena which are attached to the or other concept which are attached to the class. So that's why that class become a little bit heavy object, and handling them in the program, it becomes a little bit slow as compared to the structure. So it is a recommended that we use the structure whenever we want to store some data. For example, good for game programming, suitable for light objects like point, rectangle, square, color. In the color, you can say that we have RGB values, what will be the color. So very light objects which are actually kind of a class. We can make the class as well, but if we are using in especially in the game programming, if we want to define some a scene in which we have points, we have rectangles, we have squares, we have colors. So instead of using the class which are heavier objects and then they slow the processing, we can use this struct so that it will increase the efficiency of the program. Okay, so that was helpful. Again, if I say that I want to define a structure that has the rectangle, and in the rectangle we know that we have width and length, and we can calculate the area. Okay, so this is our structure. So if we look at that, we have my rectangle, and then we have int length, we have int width, which are the private members or the private properties of this structure, and then we have my rectangle. We have defined a constructor in which take the length and width, and we assign them to this one. We also have the int length and int width, that is more like what you can say that set and get method, how we can access those private members of this structure, and then eventually we have that particular specific area. And area, you know that if we multiply the width and the height, we get the area of the area of a rectangle. So how we can use that particular specific rectangle? So consider that we are using that my rectangle is equal to new my rectangle. So we can use that particular specific thing. The reason is that even we have not defined the default constructor is automatically defined for the classes as well as for the structure. And then we can say that we are saying that in the next line that the my rectangle dot length is equal to 12, my rectangle dot width is equal to 12. We can change it to a different number, but yeah, we have say that length and width are same, and then we are trying to calculate the area of that particular specific. It is just like a class that we are using, and then but actually it is not a class. Okay, so we are saying that console, and we can print the area, so we get the area of that particular specific rectangle. If we do something like this, like we have my rectangle, and then we try to use that rectangle, let's say that that particular specific thing has not been defined, or we cannot identify that. So we have to initialize those particular specific with construct a new structure if we want to use it. Okay, or before we can use a structure, we have to first initialize or create that thing. We can't just say that my rectangle, it's not a default thing. So when it is not a default thing, so what will happen? It will say that I could not understand, that will become a compiler error. I can't recognize this is a null pointer assignment, because at that time we have not created a structure. So it is by default assigned to the null value, and the null value something we try to use a method in the null value, so that is not possible. On the other hand, if we have defined the variable my rectangle to new rectangle, so we have created the structure, and then the default value for these integers that we have defined in our class, if we go back to our class, so we have defined these integers, and when we create using the default constructor, which we have not defined here and we cannot define here, So these values will be initialized with the 0, that is default value for the integers when we are initializing the structure. So it will automatically initialize the length and the width with the 0, and when we try to compute the area, so definitely it will give me the 0. And we can also use the constructor to define the rectangle using the constructor that we have defined. So new my rectangle, and then the 12 and 8. So if I just go to the class here, if you can see that we can also have, like, we have this is our my rectangle, and then remember that in the rectangle we can also have something like the perimeter of rectangle. Okay, and then of course we don't need to provide anything, and we can say that it will return us the 2 multiplied by, where is my cursor gone, 2 multiplied by underscore length plus underscore width. So we can also have something like this. What is saying that it's public my rectangle perimeter rectangle. Okay, not all code paths return a value. Okay, so show the original contents. Let me see that what's the problem here. So only the assignment, call, increment, complement, and a new object expression. Underscore length plus underscore width. Yeah, that is fine. Expression can be used as a statement. What's the problem here? We are saying that public int have we defined something here? No? We are just saying that public int, these are the integer values, and then we say underscore length underscore width. We are adding them together, we are multiplying with 2, and we get the answer. Okay, this is the problem here. We actually misspell the return. Yep, that's fine. So we can have as many what you can say that as many methods that we want to define in the class. Okay, not in the class, in the structure. Okay, so let's see another example that is suitable for the light objects. We have a point, rectangle. We talk about a rectangle. Okay, so now we can talk about what you can the point, and you know that if we talk about a point, we have in the two-dimensional plane x-axis and y-axis, we need to provide the x1 value and the y1 value that is represented a point on the 2D plane, and then we can find out the distance between two different points. So we have a distance, there's a formula. So we subtract x2 minus x1, take a square, y2 minus y1, take a square. We add these values and take a square root. That will give us the distance between the 2 points. So we can define a point. So we can say that int, it's a public value, int get and set methods. We can get and set these values. My point, we can define it, and then these are the public what you can say that the parameters or properties. This is how we can use that particular specific point. We say new point, we can say point 1 dot x is equal to 35, point dot 1 is equal to minus 12, and similarly we can define a method which can compute the distance. So this is already present in a point. Okay, that is in a point structure. So we have to give another point which contains the x and y values, and using those values we can find out the distance. So we are say distance points distance point is equal to math.sqr, sqrd, there's the square root, and then here we are taking the power of the x point dot x minus this dot x. So whatever that point is coming in, we are choosing the x value for that point, and we're subtracting the x value of this point in which this particular distance method exists, and then we are taking the square. And the same thing we are doing for the y coordinate, y2 minus y1, and taking a square. We're adding these two values together and then taking the square root, we get the distance, and eventually at the end we are returning the distance. So okay, so that is where we are actually computing that particular specific distance. So here how we can use those, we have a point, my point, point 1, we assign the x and y coordinate, then we define the point 2, that is again we using the different constructor and assigning the values, and then we say console.writeLine point 1, we are printing the point 1, printing the point 2, and eventually we are printing the distance between the points. So this is the output, you can see that. So distance between the 2 points is 37.74. We can say that what unit we are using millimeters, centimeters, so it depends on the scale that on which you have put that particular specific what you can say that the XY plane. So that is the structure. And now we talk about the collections. So in this collection is a specialized classes that hold many values or objects in a specific series. It is more like a what you can say that collection is more like an array, but when we defined an array we have to give the value that what will be the size. On the other hand, the collections, we don't need to specify the size. It means we can say that these are the dynamic arrays which can grow and shrink based on our requirement. So we have different types of collections which are available in the which are available inside the C# libraries. We have non-generic collections, we have generic collections, we also have the concurrent collections. The concurrent collections, concurrent programming is more like, I don't remember that I give that example in your class or in another class, but consider that we have what you can say that we have let me bring the pen first. So consider that we have a person A which has a balance of $100 $100 of balance. Then we have two persons which is the B and the C. A want to give $50 to B, it means it is give 50 give the $50 to that C, and then C is actually depositing, he's depositing around $100 into the balance of the A. Now the problem is, if they are not concurrently saved, if the concurrent programming are not been implemented, then there is a possibility that B and C are executing the operations, deposit and the withdrawal at the same time. And if they are withdrawing and depositing at the same time, they go and check that particular specific balance. Okay, that particular specific procedure, it will go and check that particular balance. It is 100, it will withdraw the 50, and the remaining balance is 50. Now this process is also go and check the what you can say that balance, and it is because it is adding or depositing the money into that particular specific A's account, so the balance will be 200 because they access the same balance, that is 100, and then they do the calculation. And now if this is going to be executed first, now the balance will become 50, and then this amount is going to be execute, or this process is going finish and go and update the balance. That will become 200. So in this case you can see that the balance should be, because we have subtracting 50 and then we are adding 100, that should be 150, not 200. And that is the problem with the simple programming that does not apply the concurrency rules, because we are accessing the same information that is the balance of A in two different processes. And if we don't apply the concurrent programming principles, then we end up with a wrong balance. Okay, so we apply the logs. For example, if that person has acquired or accessed this balance first, B or C, if B has accessed that particular balance first, then it will log that particular information. It means that C tried to access that particular specific balance and it could not access at that time. The reason is that B has logged it. Once and unless B has finished that particular specific updation of the balance, C cannot access that balance. So that is the concurrency rules that we normally apply, especially in the kind of features when we are having the common data or the common information which are accessed by the multiple processes, and to make them more accurate and reliable, we apply the concurrency principles to those kind in that situations. So we also have the collections which are present in the C#, which actually implement these concurrency principles inside those collections. So first thing we were going to talk about the and then the second thing is that the every collection has class implements the I enumerable. It means that we can, for each loop we can use for these collections. How we can do that, we will see, but it implements that particular I enumerable interface, and that's the reason we can use for each loops with these generic or the non-generic and the concurrent collections. So let's start with the non-generic collections. So it is a non-generic collection, that is ArayList. If you click on that particular specific link, it will take you to the documentation of that ArayList. Contains elements of the different types. It can contain elements of different types. Do not need to specify the size. As I told you, that we do for these collections, we don't need to specify any kind of size. They are dynamically growing or shrinking based on the number of items or number of elements in that particular specific collection. This is how we can define it. For example, we have ArayList, that is the class name or the collection name, and then we say variable name and then new ArayList, and then we have capacity and count. So when we are defining the variable, it is possible that the capacity will be 0, and then we say that we can change that particular specific capacity. Array.capacity is equal to 5, and then we try to print it. It will tell me that the first, when we have defined that particular ArayList, the capacity is 0, then we change the capacity to 5, it becomes 5. It doesn't mean that capacity will remain 5. Okay, we have defined, so okay, put that particular capacity to 5, we can add the elements, and once that it has reached the capacity, when we are adding elements in that particular specific ArayList, then once it reaches the capacity, automatically its capacity will be increased. Okay, this is not necessary that we have defined the capacity to 5, so it will remain 5. And then of course we also have the count. Actually, capacity, it will tell how much maximum elements can be saved in the ArayList before its capacity can be increased. Okay, but the count, it will show me the actual elements which are present. If you look at that, we have defined our ArayList, then we are look at the capacity, change the capacity, again print the capacity, print the count, and then we get that we have 0 element. Capacity is 5, but there is 0 elements or 0 items present in that ArayList. Then we also have the .add method, which is present in that collection. So we can add, we are adding the double value, then we are adding a string value, then we are again adding a string value, then we have adding an integer value, then we are adding a character value, and then here in this particular specific you can say that when we are adding those things, it will automatically grow that particular array list. And here in that particular specific part, because this particular array list has implemented the IEnumerable interface, so we can use the for each method. So we are saying for each variable val in the array list, so whatever that particular variable that is present, because now we are using the var, because we don't know that what will be the first element, what will be the second element, what type. So we are declaring a kind of dynamic type of the variable which can hold anything inside it. So then we are printing those values, it will print all the values on the console. Okay, so that is the for each. For each, if we have an integer array, then for each int x in that particular integer array, we can access using the x. So this is the for loop. We also have some other methods which are present. We can add a range of elements, multiple elements. We can insert or insert range, insert one element or a collection at a specific index. Add range mean that we are adding at the end. Insert mean we are inserting at a specific index value. And again, if I just go back here, so it is the index value 0, this is the index value 1, this is the index value 2, 3 and 4. So if the index values are there, so if we want to insert something at the index value 2, so what will happen, this 2 will be moved forward and there will be other elements which are present, which are inserted between the applied data structures and the quarter 2. So insert, we can insert a range, multiple elements. Insert only one element. Insert range mean we are inserting multiple elements. Remove, we are trying to remove an element or a range. Remove at, we are removing the element at a specific index. We can sort them provided that they can be sorted. If we look at this particular specific array list, this contains the multiple different types of elements. So if it is containing the multiple different type of elements, that definitely we cannot sort it. But provided that if the array list can be sorted, it can sort. But reversing the order of the elements in the array list, again index of, contains, clears. So these are the different methods which are present in the array list. Then we have the second collection, non-generic collection, which is sorted list. And if it is, look at the name, we can simply say that that will be a list of the sorted elements. So it is a key value pair. What is a key value pair? Key is more like, it can be anything. It can be integer value, it can be a character value, but it will be something like which is actually representing, you can say that it's an index value, okay, but actually it is not. So it is, we give the key, and then whatever the value is that is present in that in the ascending order of the key by default. So whenever we are adding the elements in that particular sorted list, they will be sorted based on the key value in the ascending order. Sorted list class implements iDictionary and the iCollection interfaces. It also has the properties like capacity and count. We can add, we can remove, we can the method that we have seen in the array list, they are also present, more or less they are present in this one. We also have some method which are related to key, get by index or get key at a specific index, get index of a specific key which is present in that particular specific sorted list, or the index of a value. So these are the few methods. So sorted list is equal to new sorted list, and then we say add, we have a 3. Now we are, this first element is the key and the second element is actually the value. So we are adding 3 and then 4, then 1, then 5 and 2. But when we try to print that particular specific key, it will always be in the form of 1, 2, 3, 4, 5. We have added them into a different order, but it will automatically add those elements in the order based on that particular specific first key. Okay, so here we are saying that for each dictionary entry DE, dictionary entry is actually representing this key value pair. We have a key, we have a value, so dictionary entry is representing that particular specific ordered pair. And then we say key 0 and the value 1, and then we say de that dictionary entry dot key and de dot value dictionary entry dot value. So we can access those first and second element using this particular specific way. And then we can also say that for int I is equal to 0, I is less than equal to sorted list dot count, sorted list 1 dot count. So this is a sorted list, and then we say 1 dot count, which will give me the elements which are present. So we have a 5 elements, so index values start from 0 to 1. So we say sorted list 1 dot get by index. Get by index, it will give me the value only. Now we are providing the index value, but we are getting the only the values, not the keys. Okay, so this is how we can access. There is another collection which is present in the C#, and that is stack. We have a last and first out data structure. We can push the value, we can pop the value. Push means we are adding the value inside, and pop means we are removing the value. Always remove from top. So consider that we have this pipeline. So the value, we are adding the value inside our stack. We are and then we are say that add and remove from the same end. We are adding from this end, we are also going to remove the values from the same end. So in this way the stack works. Right on the top value, if we add, it will add it on the top, and when we are removing, the topmost value will be removed from the stack. So we allow null values. We can put the null values in this particular specific stack. It can also allow you to duplicate values of the different types. We can put the different duplicate values as well. Push is a method which actually help us to add an element, and pop, and which is retrieve an element and remove it from it. And then we also have property, that is count, which will show us how many elements are present. Clear mean that it will remove all the elements from that particular specific stack. Contains, if we want to see that if specific element is present in the stack or not, so we can find it. So this is the example. So we created a stack, we create that particular specific stack, we are adding the value. So we add my stack, then we put in null value, then we are pushing the integer value 1, then we are pushing the integer value 2, then we are pushing the integer value 3, pushing the integer value 4, and then at the end we are adding the top of the stack. So we add those values in the stack, and it will be stacked like this. And when we try to remove, so we stack dot count is not equal to 0. So we know that this stack is 1 2 3 4 5 6 7. So it has 7 values. In the beginning, stack dot count is 7, and it is not equal to 0. So it will say that pop the value and print that particular specific. So when you say pop, it will remove that particular specific value from the stack and give us as a return type, return value, and then that is printed on the screen, on the console. The same thing we can do with the 4 3 2 1. Then we have a null value, then we have my stack, so it is printed this way. So where we can use the stack, first of all, remember that we talk about the last part, the recursive stack. When we talk about the recursion, the operating system automatically maintain a program stack or recursion stack. So that is also an example of the stack. The last method which is go into the recursion stack, that is the first one that is going to come out. So reverse a word, whenever we want to reverse, so we first push all the characters in the stack and then pop them all. It will automatically reverse that particular specific word. Undo list, that is normally maintained in different programs, that is also kind of a stack. Varying or removing the bangles, syntax checking in the programming language, they all use the stacks. Okay, so these are the some examples where we can use these stacks in our real life scenarios. The second or the next collection is the queue, is a first in first out. Whenever you go to the cinema, you make a queue to get a ticket. If you want to enter into the cinema house, then again you make a queue. Whoever in the first place, he will be entered into that. So first come first serve, or first in first out data structure. And queue, adding the element, and then we can say insertion end. here the insertion and the deletion end or the removal end, they are different. Okay, so we are inserting the elements 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, and on the other hand, when we are removing the element, we are inserting from this particular specific end, but when we are removing, which is who is the at the top of the queue or the front of the queue, you can say that, not the top, front of the queue, that's a 1. So we are removing from the other side, removal end, that is a different from the insertion end. So we can remove those elements. Again, it allow the null values to be added in that one. We can also have put duplicate values in that particular specific queue, and queue is a method which will help us to add the elements. DQ is the method which is to retrieve the element. We can also peek. Peek mean that we are not removing the front element but only looking at who is at the front. So that is more like a P. So we are retrieving the elements but not removing when we use the peek method. But when we say DQ method, it will not only look, it will also remove the front element. Again, we have a count how many exactly elements are present in the queue. We can clear the queue. Clear the queue means it will clear all the elements which are present. They will be the queue will become empty. We can also find out that a specific element is present in the queue. So here's an example of the queue. So we are just queue. This is the class name of the collection or the collection name, and then we have the variable name. We are initializing that particular queue, and then we are adding the elements. Okay, and then finally when we are going to remove it, we can remove it. So here we say write.console number of elements in the queue. So if we say number of elements, it will give me the 4, and then we say that while queue.count is not equal is greater than 0, unless and until that particular specific count is greater than 0, we are dequeuing and printing them on the screen. And once it is become 0, then it means that there is no more element present in the queue. That particular loop will finish. Then we have the generic. So first of all, we need to understand what is meant by this generic, and then we can talk about the generic collections. Generic collections we will talk in the next lecture, but right now we understand what does it mean of the generic. It's a type parameter. Defer the specification one or more types until the class or the method is declared and instantiated by the client code. Actually, it defer the, what you can say that what kind of what will be the type of the variable or what of the type of the parameters that has been deferred till the compile time. Okay, once we are using that particular specific object, and then we can tell that what type of the array list or the sorted list or can be. So here we are say multiple in the sorted list we have multiple elements of different types of elements, but normally that is not what we want, because we want to create an array but of the same elements. So we can specify that particular specific time at the compile time. When we are compiling the program, it will automatically infer or deduce or check that what is the appropriate value or type of that particular specific generic type. For example, we say that my generic class T, and now T is something which is like we don't know what it will be unless and until we come to the when we are compiling the program. Advantages: code reusability, type safety, and the performance. So of course we are using the same type or same kind of code for the integer values, for long values, for short values. So we don't need to write the program again and again. It's the same code again and again. So code reusability, type safety. At the compile time we can check the type, and it also improve the performance. So it can be applied, that particular generic can be applied to the interfaces, to the abstract classes. What are the abstract classes? We will discuss in the fifth lecture. This is the third one. So in the fifth lecture we will be discussing that what is abstract class. we have a class, method, properties. We can apply that particular generic types on the a lot of different places inside the programming: delegates, operators, events, structures, properties, methods, classes, and so on. So this is an example of the what you can say a structure. We say generic rectangle. Now we don't know that particular specific length will be the integer type, or the short type, or the long type, or the float type, or the double type. So now we are using that particular specific t. We have a generic type t, and we are defining that length and the weight of the generic type t. Then when we are initializing, or when we are using the constructor, so again we say t length, t width. So it will we will assign them to the length and width, and then we say calculate the area. So we say dynamic. Now because we don't know what will be the type of the length and the width, so we said dynamic, because we want to know, we can't perform the what you can say that the mathematical operation on the t type. But when we convert those into the d1 dimension 1 and dimension 2 length and width, and then we multiply them together and we get the answer. So what happened? For example, we are using that particular generic t. We say generic rectangle, and then in these greater than or the smaller than, we are putting the, inside of t we are putting the int. It means that that particular int is going to replace in all these places at the compile time. When we are compiling the program, it will look at that particular specific line, and then it will assign the t as an integer value, and then my generic rectangle, and then we have all those things, and then it can perform exactly the same way that it has done before for us. It compute the area of that particular specific rectangle. But using the same code, we have the same code, and now we say that no, we are want to define something double. So it means the length and the width will be double, and then the area will also be a double value. So we can do that. Again, we don't need to rewrite the code for the double values. We can use the same code that we have for the generic rectangle, and here we only just change the double, so it will automatically assign the t values with the double value. So automatic. So at the compile time, it will decide that this particular t will be an integer value, or the double value, or the long value, or the short value. So you can, whatever you want to use. Of course, you want some numerical value rather than string values, so that need to be very specific. So specify which type of the placeholder type. We can also put some constraints, like here we don't want to put something with a string. We can only use float, double, short, int, long. We can numeric type values rather than the string or the character. So that's why we can put some constraints. We can, when we are defining that particular specific class or the structure, then we can say that where that particular t, what are the possible values of this t could be. Okay, type with the generic class is allowed. Specify which type of the placeholder type with the generic class is allowed. Compile time error in case we are trying to allow a different type rather than the types that we have allowed with that generic type. If we try to use the assigner different from that particular spell, which is different from that constraint, then definitely it will give us the compile time error. And we use the where is a keyword that we are using to assign. So we are saying that only a reference type or the non-primitive type structs or var are allowed here at that particular specific my generic class. Okay, so which type of the class it is. Again, we have a if you try to find out more information about how to apply those constraints, you can go into that particular specific link, and then it will give you more details. So we can say that it can also have a struct type as a generic. We can have a new base class name, or the interface name, or the view. So these are the things that you can use inside our when we are defining the constraints. Okay, Then we have the generic collections that we are going to talk about in the next lecture. We have a dictionary, we have a list, we have a queue, we have a stack, we have a sorted list. So all these are present in the C#, and we will be discussing in the next class. So these are the some links, and I hope you have enjoyed our lecture. Thank you. Bye.